With us, we've got Greg Lavender, the Global Head of Cloud Architecture and Infrastructure Engineering at Citi. And he's going to be working through a panel of some fairly famous people to talk through how to use hybrid cloud services with split application architecture. Thanks, Greg. Over to you.
Yep. Okay. Thanks, everybody. So I'm going to have just a few questions that I'm going to kind of throw out at the panel, and I may target them at a couple of people initially, then let other people sort of jump in if they have thoughts. And also, there's going to be some live polling questions going on during the session. So if you've signed up with your phone for the live polling, you can answer those questions. So first, let me introduce the distinguished panel. It's great to have this collection of folks, both from the sort of the cloud, we'll call it the cloud technology area as well as the network technology area. So as these things are converging, and we're all sort of facing with it. Just as a brief side note, I spent most of this morning over at Goldman, where there were CTOs for cloud or infrastructure from Goldman, Bank of America, Morgan Stanley, Fidelity, myself, along with the CTOs for cloud at Google, Amazon, and Microsoft. Really just sort of talking about some of the issues, some of which are the questions I'll ask you. Since we didn't have the answers in that meeting, maybe we'll have the answers in this meeting. But one of the outcomes of that will probably be a working group to kind of standardize some of these technology questions and concerns and try and get sort of, because they're not competitive from our perspective, they're just things we need. But so we have Tim from Google, we have Toby from Docker, Mesosphere, Ken from Arista Networks, Martin from VMware, Dave Ward from Cisco, and Madhu from Docker. Yeah, so great panel. And I said this when I did the town hall last year, is and it's not a sales event. It's like your personal brand is what everybody wants to hear about, because you are industry experts. You have unique perspectives. It's not a competition. I think it's just a way to educate and inform all of us on your points of view, and give us advice on how we should go forward with things. So just to draw on one of the questions from this morning, all of us are trying to figure out how we can do sort of a hybrid cloud model, which is essentially an extension of, say, our private cloud data centers. And so, obviously, the first place you have to work on is that WAN edge connection that would go out and direct connect you, or however you want to direct connect out to a cloud provider. And the challenges that you'd have in that sort of place, because as banks, financial institutions were regulated, so having good security controls in place, good audit controls in place, QoS controls in place, and being able to sort of stretch our network securely out into the hybrid cloud environment, let's say to an Amazon VPC, that's sort of a new kind of networking design for many of us. Telcos have done that kind of thing before with, sort of WAN edge technologies for MPLS, et cetera. But, the semantic functionality that's now having to be placed there, and the controls and the visibility and observability you need stretching all the way out into this other cloud-provided data center is introducing some new challenges which sort of fall back into software-defined networking. So maybe I could start with Dave and say, Dave, you have thoughts on how we should approach this kind of problem?
So I think you said it right. It is really a software-defined networking problem, where it's not just being able to provision a circuit, a tunnel, whatever, label switch path. Yes, you definitely need to do it securely. The issue becomes not only just provisioning, whether it's dilating a TE tunnel or extending your VPN and doing the addressing. I think those are pretty much known technologies and available, even on the public cloud side. You're able to use private addressing, and that's okay. The challenge that really is emerging, and you alluded to this, is the telemetry coming back out. Are you getting what you need to get out of that circuit? Because frequently it will be cross-domain, as you're well aware. You're either going to go for a dedicated circuit right into that public cloud, which most of the public cloud providers offer, but still, is that going to be going across the public internet? Are you going to have to be able to orchestrate these cross-domain? If you want guarantees and you want to do a label switch path, how are you going to do that interdomain? There's 42 different ways, and I apologize, I was probably involved with 41 of them. 42 different ways of doing that, of various levels of functionality and whatnot. But where I'm headed with this is the choices that need to be made is, and hasn't been addressed by software-defined networking extremely well, is I think you can do your edge. I think you could even potentially do a circuit or a guaranteed bandwidth into a public cloud. The interdomain pieces are extremely challenging, and without having the analytics or some notion of understanding how your data is going to that to that public cloud, and you're doing this just over IPN cap, which might be a way that folks are saying, well, look, why don't I just throw this into a GRE or VXLAN or pick your favorite encapsulation. You are then totally at the whims of where that data is going to go across the public internet. And in a regulated environment, your compliance of national boundaries potentially, or of other guarantees are extremely challenging. If you don't mind, I have the mic, so just one last point I wanted to make. And maybe this is part going towards the hybrid cloud architecture conversation for the panel, is the IO guarantees out of a public cloud right now are really not part of the application definition. We're able to have a definition of an application that needs a certain amount of CPU, a certain amount of RAM, a certain amount of storage, but the IO is not there. And so that, when you measure the quality of the cycle completion time or of what you're doing in the public cloud, you definitely have the WAN link to get to the cloud, but then how do you have the IO guarantees within that public cloud? And that's probably at the state of the art today, or certainly I think part of the conversation that we should all be having. Is that a necessary step that we need to take in cloud architectures in general and public cloud architectures, that IO is a variable? And I think the container companies here are working towards that direction, but it's an interesting conversation because end to end, all the different pieces need to line up for you to get your money's worth out of bursting or having this hybrid cloud situation.
And just one other comment on that is we all want a VPN. It's all going to be encrypted, and so therefore key management, where we hold the keys on our side and use the keys to encrypt or decrypt whatever stored or used in the cloud, adds another layer of complexity on top of the basic networking. Maybe we can switch to Ken, get Ken's views.
There's no shortage of challenges with getting applications running in the hybrid cloud, in the public cloud, particularly when they weren't designed that way. I feel like the way to start is to start with a new application where you don't have all the dependencies on your existing infrastructure, but can pick something which is really specialized and works well in the public cloud context. Start there, and that dramatically simplifies the requirements in terms of what quality of service do you need for that backhaul from the public cloud back into your existing data centers. Get that working first. Walk before you try to run. And then the operational experience you gain there will inform the extent to which you need guarantees, SLAs, telemetry data to verify them. That will really depend on the nature of the application. And certainly the more to which you can specialize and have applications running in the public cloud that aren't dependent on lots of real-time access of state held privately, but are rather able to run more or less autonomously, synchronizing state in the background on a periodic basis, you'll be much better off. So keep it simple would be the main thing I would focus on.
And we have to keep it simple, otherwise it'll be too expensive. So one of the things we talked about too is whether there's an opportunity in the marketplace for a vendor to produce sort of a cloud edge in a box, so that we're not all trying to solve this independently with different technologies, that somebody just offers a standard kind of turnkey system that maybe even the cloud provider manages, like it used to be the telcos would manage the sort of customer premise edge. So those are thoughts. Anybody else want to comment on this particular topic? We go to another question. It's a very networking centric topic. So, okay. Well, so let's assume that we solve that problem. Or maybe somebody from the audience might want to have a question related to that particular one. Let's assume for a minute we can solve this question because we're all working hard on it and spending money on it. So then, well, why are we doing it? Well, the reason we want to do it is we want to do some clever things like auto-scale our grid computational workloads so we can burst out into the cloud to grab additional CPU cycles, setting aside the data I/O issues and data access issues of doing things over the WAN, just being able to sort of auto-scale yourself out quickly. So we have competing technologies now, right? The vendors will spin up a VM for you. The cloud vendors, cloud service providers will spin up a VM quickly, but we all know that you can spin up a container much more quickly, right? So maybe we turn to this container VM question and talk about how we could leverage that. I'll start with Martin on that one.
By the way, I think the poll we should do is polka dots versus zigzags.
Okay, that's a competition.
Yeah, so I think this is an interesting question. I view containers as an infrastructure abstraction to be actually very fortuitous for all of us in the room. And let me explain why. So clearly applications are evolving, and they're evolving in different ways, right? We've got different paradigms in different ways, and the application is reaching down into the infrastructure. Now we need infrastructure level abstractions to kind of hold this together, and those abstractions could have looked like anything. right? If you look at like kind of the general evolution of software, it could look like some random Java object, or it could have looked like some policy-based language or something. And instead, that infrastructure level abstraction looks kind of like a machine, right? I mean, it looks kind of like a machine. It's got an interface on it. It uses L2 frames and so forth. So as infrastructure guys, we know how to manage these. I mean, certainly I know, like for example, the product that I work on, we've been using or supporting containers in production for a long time. And the only reason that we could do that, the only reason is because they look familiar. If infrastructure had changed to something entirely unfamiliar, right? And like some random Java object with a new wire protocol, there's no way existing tools, operational tools, or existing tools such as like network virtualization tools could actually plug into them. So I think it's great. They solve a very specific problem. They're very useful, but also they are similar enough to things that we know, like virtual machines, that we can just go ahead and integrate them to the environment without doing massive disruption to the organization or massive disruption to the tool. So I'm all in.
Madhu?
All right. So Martin is right? So if you look at containers as a VM, it's easy to manage, straightforward to maintain, and so on and so forth, right? But the next level of application architectures is actually changing the way we look at applications. Really, distributed applications see containers as not just VMs, virtual machines. They look at it as a fungible entity, right? Which we don't actually assign any value to that. The containers can just come and go, right? Just like if you look at Kubernetes, the approach about just have a model where applications can just come up, run in your laptop, or just run in your public cloud and a private cloud. It just happens, right? The reason that it happens is not because the containers are running like a virtual machine, it's because of the simplicity that containers provide for the application, right? So Docker as an example, it encapsulates not just the namespaces and C groups, it also provides this application packages, right? That's the fundamental difference between the applications running in a container and a VM, where container doesn't carry the heavyweight packages that a machine carries today, right? It is so lightweight, it can just, as you said, it can boot up in milliseconds, right? And you can, if it dies, it's fine because we don't attach, it's not a, people talk about pets versus kettles, right? But people start calling containers as ants now, right? It's tiny, it's not even cattle, just don't attach your value to that. Rather, attach the importance that applications require microservice architecture, of course. And then, if you, but the other side of things is that if people want to see containers as a VM, because people just move slowly towards a new application architecture, they can still consider containers as a VM. The great thing about the virtualization company like VMware is that they educated the customers so far on what is virtualization, what it can provide. So they can see containers as a VM and start managing it that way. But as it scales, it has to become kind of an ant and start managing it like a better architecture system. And then applications really take over containers as a simple entity, not as a massive machine which we have to manage.
Yeah, great. So I think I was going to switch over to you guys just because I think if I add on to that original question, you can answer that, to give your thoughts on that original question was, okay, so great, I can spin up a few containers. What if I want to spin up hundreds? How do I orchestrate, manage, and not just the spin up, but the spin down? So it gets right in both of your areas, whether it's Kubernetes or Mesos.
So just to add real quickly to what Madhu was saying, I think the thing that Docker did and that containers do that is exceptionally good at this time in the industry is they play to software engineers' model of good software engineering, right? Containers are the object in the next level of higher level language, right? You don't think in terms of a C++ class or a Java class. Now you think in terms of an object and a container and a microservice, and what interface does that thing provide, and how do I manage that, right? And so I think as developers, it plays strongly to the things we already understand and know as best practice. To the question of orchestration, you don't get very far into container space before you realize this is actually really sort of hard to manage, and ants is actually a really cool analogy. I like it because have you ever had your hand covered with ants? Like, oh my God, what do you do, right? And when you launch 100 microservices in your fleet, and now you've got to manage them, and you need something to handle the death of machines and the evolution of your workload and versioning and those sorts of things, which is sort of where we came at the problem with Kubernetes. It comes from our internal systems, Borg and Omega, and we've got some experience doing this for a few years, and so we wanted to sort of come out and share some of the patterns that we've figured out over time, because some of them are obvious and some of them are less obvious.
Yeah, so I think with container orchestration, there's really a couple of challenges. So first of all, because containers are so lightweight, we use a lot more of them. We use many more containers to build a modern application than we used VMs in the past. Then especially in a hybrid environment, you have policies that you need to follow. Not every workload can run on the cloud. Some have to run on-prem. And you have SLAs that you need to meet for your application. And so that's a challenge for a cluster scheduler like Kubernetes and like Mesos. And I think sort of in the early days we've built schedulers for that schedule compute and memory and like bin pack our containers onto machines. I think sort of the next step is to actually expose more information from the infrastructure, like what is the network latency between those 2 points, and what are the network fault domains, what's behind the same switch and things like that, and actually surface that information and use it in the scheduler to optimally place my application to meet a certain SLA, to meet uptime requirements, policy requirements, all that stuff. So there's really a couple of axes that make this a really hard problem.
Just want to remind everybody we have the polling questions, so hopefully this is really fascinating. So hopefully remembering to answer the polling questions. So I'll throw another little harder ball question out there, given that sort of foundation we just talked about. So when we have lots of VMs running, we sort of, even though VMs can be suspended and snapshotted, typically at least in our data centers, we have tens of thousands of them running. They're running sort of, some applications have 700, 800 VMs all talking to each other. If we're lucky, we get all the virtual networking plumbed and everything's kind of nice and working well, and they're micro-segmented, and maybe there's a firewall and the load balancers and the dynamic DNS updates have all happened. And I'm spinning up hundreds or thousands of containers up and down, bouncing all this stuff up and down. How do I keep load balancers, firewalls, DNS, my virtual addresses or my NAT addresses, whatever, sort of managed? Because that's quite a bit of churn that can be happening very, very quickly, like on Black Friday or Cyber Monday. So maybe, but we'll just open up to the whole panel, so we can just start with Madhu and just come right down the row.
Sure,
on that one.
Yeah, of course, it's an excellent question, right? So, and we are lucky to be in this DevOps moment, right, where the days of a single operator managing this kind of a complexity is gone. It's way behind us, right? So it has to be automated. It has to be automated. It has to be orchestrated. We need a strong container management solutions, and that's why we have Swarm, which, shameless plug, Docker. We just released Swarm 1.0 as of yesterday in production, right? Which does the orchestration. We have Kubernetes, we have Mesos. So we need these strong software orchestration system to be managing those. We cannot be relying on people to manage tweaking these load balancers or any of this, right? We need strong models, right? Container has a great model for applications. Like that, we have good models for services, which has been coming out in all these various cool technologies. So we need to start using them. We need to change our mindset to make sure that DevOps culture must go inside every single aspect of how we do. Whether it is network operations or server management or container management, it should be under a DevOps wrap, not siloed ones.
I think it's a really important point is we're all good at sort of throwing technology at problems. It takes people and process time to adjust and change. I think that's kind of an inhibitor, at least I see, with the speed of which we can adopt some of these hybrid or public cloud services.
Exactly.
Dave? We'll just come down the road and everybody get a chance.
Okay, so we use all of these and partner with all of the container guys up here and with Martin, of course, as well. We partner less with Ken, but that's another story.
but you will exchange L3 packets.
I couldn't resist. So I'm going to be a little bit more controversial about this. I do think it's possible to dole out IP addresses to containers fairly quickly, but the controversial part is that networking for container, the architectures around networking for containers is really in its infancy. In some, insert your binary plugin here. Useful, but not interchangeable with everything you just said you wanted to do. I need load balancers, I need firewalls, and I would prefer architectures in which We aren't trying to manage vast, massive overlays associated with tens of thousands of containers going up and down, basically instantly, as you described, and frankly, that's the way we use containers as well, and we can talk about the use cases in a second. But where I'm going with this is the host container and in this particular case, or this particular point in internet history of being dependent upon Linux kernel networking is a challenge. I'd love to see all of that get to user space. I would love to see something beyond just insert your plugin here, instead that there is an industry, I don't want to say standard, but there's at least an ad hoc standard among industry players that we know how to be able to do better networking, according also for I/O requirements, et cetera. But for the massive agility you want, where your containerized applications do require a certain amount of those networking services around them, it is a challenge to manage today, and it is a challenge in container architecture. Now, that being said, it's also a monumental challenge in hypervisor management schemes as well. And so the industry in general really needs to work to solve this problem, and I do think that's a good place for working groups to form.
All right, so I'm gonna take a step up. So I mean, I think that basically we as an industry have kind of been flubbing this problem for decades, right? So the problem is as follows. I as a business want to use infrastructure, right? And so I as like a policy wonker, security wonker, a business person have an idea of what I want to do, and I think in terms of people and data and whatever it is, and then infrastructure is supposed to implement that. So somehow you're supposed to go from like a high level like understanding of things down to these low level addresses. Now, if you went to an operating systems guy or a languages guy and say, how do you do this? He'd say, you know what, I'd build this domain-specific language where I'd say, Martin can or cannot access this, and you know, then I would have a compiler that would compile this down to these low-level directives. That's what compiler guys do, right? In networking, this has been very difficult for 3 reasons. The first one is kind of the mechanisms that we have to implement policy are topology independent, which means if something changes, then the semantics go away. So if you're using IP addresses, they don't really mean anything and they're topology dependent. 2, you got this massive distributed state problem where like if you want to implement a policy like Martin can or cannot access something, I've got to run around and manage it. And like distributed system state maintenance is hard for programs. It's an impossible with human beings, right? I mean, listen, we're forgetful, we get hungover. I mean, it's just really a hard problem. And 3, we've always had this device canonicalization problem, which is like, you know, in order to do this, I've got to talk to these devices, but they all look different, right? So in order to build like a compiler, I'm going to build this compiler that allows you to like manage this operation, like this high-level language. I'd have to talk to Juniper and Cisco and all of this other stuff. So it's important to realize that network virtualization, and it doesn't like as a concept, not as simple, forget overlays, forget products, as a concept, it solves these 3 problems because it provides a level of abstraction, like computer science always does, a level of abstraction that's decoupled from the physical realities. What does it do? It's, you know, it's topology independent. You've got this logical platonic space that's an erector set for creating stuff that you know. Right? 2, it solves a distributed state problem. I've given you a centralized abstraction that you can go ahead and put your policy on. And 3, it's a canonicalized abstraction, right? It's like this kind of canonicalized view that kind of hides the stuff below it. So given a real layer of indirection with real abstractions that make sense, I think you can build beautiful policy layers that actually manage the complexity of this problem, just like operating systems have been doing forever and languages have been doing forever. I just think we need to view this as a systems problem.
So are those abstractions mature enough now for us to really kind of?
No, we're in the chaos phase, and like I'm saying, let it rain, and like I'm all for chaos. Like I think it's great that there's so much technology and so much excitement around this, and we should keep this happening. And like you know, over time, markets will pick it and communities will pick it. And I actually think we're just starting the policy battle, right? The next thing is like, what is that policy language? You know, what does it look like? What is the namespace? Like, what can you like say policy over? Like, we haven't even gotten there yet. So listen, we're like in like a renaissance and a golden era of networks becoming distributed systems. So let's all revel in it and enjoy it. And I think you're awesome, Dave.
So I tell my friends I'm going to be gainfully employed for at least the next decade. Ken?
Yeah, I really agreed with a lot of what Martin said, and I'd emphasize the value here of separating the physical infrastructure from the virtualized network where you're trying to solve all of these problems related to managing the address space, providing access control to the right resources, and having a policy language, a policy enforcement mechanism. And just like Martin said, we're in the early days of this. There are a lot of competing approaches to how to solve these problems. I mean, in my view, the world looks a little bit like the world of layer 3 networking around 1989. If you can remember back to those days, anybody remember?
Tuba.
You've got like Tuba, hey.
TCP would be a good address. I was there too.
The main show in town was IPX, right? And then you had DECnet and XNS and NetBIOS and NetBUI and AppleTalk and Banyan Vines. And, this is an environment where 1,000 flowers were blooming. There's a golden age. And what customers needed was a physical infrastructure that can cope with all of these disparate alternatives, because customers typically needed to run more than one. Didn't know for sure which one they'd need. And we're waiting for things to shake out. And it took, 20 years or so. And now here we are in 2015, and the layer 3 wars are over. There's V4, there's V6. There's no other game in town. But network virtualization, for a lot of the reasons that we're talking about here, in terms of the policy languages not being clearly defined, there's no one clear solution, no one standard where this all makes sense. You need a physical infrastructure that supports all of these alternatives. And what you really don't need is a physical infrastructure and a vendor telling you they've solved this problem. Because they haven't. As an industry, the problem will be solved the way Martin said. There will be the standards will emerge. Multi-vendor, federatable, separate administrative control. And while that's happening, you need a physical infrastructure that integrates with as many of these as possible. And that's our approach.
Yeah, so the way that some companies that use containers at large scale have solved this, I've never worked at Google, but I think you guys are doing it too, is you have control over the RPC stack. And so Twitter does this, Facebook does this too. You basically do discovery and all that stuff through your RPC stack. And those companies have the luxury of being able to prescribe the RPC stack for all the applications they build. And so you can discover applications and set policies using higher level primitives such as labels or environments and things like that. So it kind of up levels it, and it moves it closer to the application developer, which I think is generally what's happening with containers. And so I think these companies are sort of paving the way there, and I think we'll see a lot of more of that in the future.
So I'm probably the least networky person on the stage. So I'm going to up level by just one step. The question was, at least my interpretation of the question, was about the software and the problem of change. The thing that I think fundamentally we need to accept in software is that nothing is the same as it was 10 seconds ago. And applications today are built around this idea of, well, you gave me a host name and I resolved the host name to an IP address, and forevermore I hope to talk to that IP address. And in order to satisfy constraints like that, we introduce things like IP migration, which brings enormous amounts of complexity to the whole stack, when you could just say, you better revalidate that name, right? And so to a first approximation, every application is broken, especially the open source ones. And they're broken because they assume that things are stable. If we can move past this, you call it the golden age, the Renaissance, it's sort of like the dark ages to me, having been inside Google, where we've internalized this through our RPC stack, where we do have the luxury of beating our developers about the head until they do the right thing. I see the world of open source, and I say, like, you can't do that. That doesn't make sense, right? And it's going to take years for us to convert this model of thinking of particularly, I can look up a DNS name. Those sorts of things, they need to evolve out, right?
Yes, I mean, it just becomes a real true utility, it's a real matter of fact as opposed to an ideal. So, I mean, I think you mentioned, I thought it was interesting you mentioned DevOps, right? Because one of the challenges I see just in our own organization is we've got this sort of cultural transformation going on at different speeds. So the networking people, they got it now. They bought in the network virtualization. So we have multi-vendor products. We've actually built all the automation to dynamically provision the load balancers and the firewalls and the network virtualized endpoints, et cetera. And we're moving more and more of our application estate to that environment. But the bulk of the cloud ops people, the people that run the data center, just don't understand this stuff, right? It took them a while to understand how to provision a VM and how to put an application into the VM. And now we're automating all this stuff out of the way, right? Which is the right thing to do. So that's going to push the responsibility for what historically you called up your SA and you called up your network administrator and asked them to do something. We're pushing it all up into the DevOps world. And so now we need to give the DevOps people even more automation, more tooling, more sort of elastic search or Splunk visibility into what's actually happening down there in that infrastructure. Because my life is always like some app guy, who calls up and says, my app is slowed down. And first they blame the network, as we all know that are in networking. And then they blame storage. And then they blame the server. Then they blame the compiler miscompiled their code. And they do everything except blame the change you just put in that morning. And that's usually where the problem is. So first thing I always do is go look at the change control system and see what software change got put into the environment that might have slowed it down the last 48 hours. But I think we have the opportunity to sort of like get out of that sort of like pattern, which is if something's slowed down, you have full visibility into the environment at some level, right? Maybe you can drill down even deeper. And to give them the abilities to understand where the control points are that they need to tweak, or maybe they need to actually call somebody. But I think it gets us to a level of efficiency both in cloud ops and DevOps. Because you have to have cloud ops for break fix. Stuff will break, hardware will break, ports will flap. Bad cables will get plugged into something. Somebody will bend the connector doing maintenance. So we need a cloud ops function, but it's small. And we need a DevOps function that has a lot of information and telemetry. So how do you guys see that area evolving? Because one of the topic of discussions again this morning in our sort of cloud working group for financial services was sort of most cloud providers don't provide telemetry as a service. It's not like some big S3 archive where I can go query it with Elasticsearch and find out all the monitoring information about my stuff running in the cloud. So what are you guys' thoughts about how as the DevOps accountability, responsibility starts to move to them, how that's going to sort of change things or what software abstractions we need to support them? So maybe I'll just start here and go back down the road.
So going first, I get to say stupid things that people can refute later. I agree completely with the premise that telemetry is key. One of the things that we accept as truth in software development inside Google is you instrument everything. Everything. We've made our instrumentation libraries so lightweight that you don't think twice about instrumenting because by the time you need the data, it's too late, right? So we instrument everything, we collect everything, we store everything, which gives us some really neat insight into, my job slowed down because somebody pushed a new version this morning and it was Joe who did it and it was change number 65213 and I can, with 3 clicks revert that change and repush it. We also have things like cluster level services that everybody participates in and announces changes to production, right? I pushed a new switch firmware, that gets logged. I pushed a new version of search, that gets logged. I pushed a new version of Borg, that gets logged. Now when you see something's wrong, you can go look at the console and you say, well my latency started spiking at 8 a.m., which corresponds to this machine or this cluster being upgraded to the new version of Borg, and then I know who to call, right?
You as a developer see that, or you as the guy running the infrastructure see that?
Isn't that the same?
Well, not in the world outside of Google.
So, in the DevOps world, the guy who's running it is the guy who's writing it, right?
Yeah.
And so, everybody can see it. These are public.
You have job openings or no?
Plenty. These are public consoles that people can go look at and they can see what's going on. To a first order, they're voluntary, like you don't have to participate in the cluster historian, but you want to, because if you're not, you're hurting yourself, right? And the first time you have an outage that you can't explain, you say, well, I actually should have logged that.
Yeah, totally agree. Log everything, monitor everything, container, disk I/O, network I/O, memory, CPU, everything you can get, human interventions. And I think the next level is sort of building a good anomaly detection system that just continuously monitors all your metrics, compares it to historical data, and just surfaces things that look anomalous before a human could ever detect it. So I think. Totally agree. It's all about getting all the data, automatically analyzing it in real time, and surfacing stuff that's off.
Don't really have anything to add.
Okay. Actually, I love having the application higher level guys here because it actually shows you how different thinking is, which is problems that just seem so obvious. What's the problem here? This is good programming. You just instrument stuff and you're done. Are like topics of endless debate in the networking industry and have been for 10 years. So I just want to focus on one of these. Okay, so here's a big topic of debate. If you have a network and you do an overlay, all of a sudden you're very confused, right? I mean, this is like this. I mean, like I've been part of this discussion for a decade, right? Oh, you've got 2 addresses. How do you know how to debug and everything else? So from a systems perspective, here's how that discussion sounds. Back in the 70s, you know, we had hardware and we had physical addresses, and it was awesome because we knew exactly where our code was running, because we had physical addresses and we had code running those addresses. And boy, if you like put in virtual memory there, then all of a sudden I don't even know where the code is running and how is it going to happen and how is it going to work. And then you start going like higher level languages and higher levels of abstractions, and how are you going to do this? And the reality is, in my experience, when you build tools, whatever it is, whenever you build tools, you focus on the infrastructure first, and then you focus on the operational tools later. It's a backwards way of thinking, but that's what happens. So there's a period of time where you've built all this cool technology like virtual memory, or high-level languages, and then it takes a while till the operational tools catch up, and then you get stuff like GDB, and you get symbol tables, and all this other stuff that like changes your mind, and it's amazing, then everybody agrees it's a good idea. So the same thing is kind of happening in the network space, which is, you know, there is an extra layer of addressing being introduced, independent certainly of product. I mean, it's just happening, right? I mean, it's actually happened many times. And as a result, people get very nervous. We've got 2 layers of addressing. How do you deal with 2 layers of addressing, right? Well, you build tools that understand 2 layers of addressing, and now you've probably got bigger state and so forth. So I think that the bottom line is tool chains have to evolve in order for these things to happen. And there is an additional element that makes these things much more difficult, that is if you're dealing with a distributed system, the problem is incredibly hard. I mean, I come from like the HPC days where you're building, you know, distributed systems on supercomputers, and like those tool chains still suck, right? And so I think like abstraction is good. Additional addressing layers are awesome, but you need to have the supporting tool chains to do it. And I wish we could all live in the world of having high-level languages. That's where the world is going for sure. But until we get there, we basically have to retrofit tools on top of existing evolutions in the industry.
So clearly overlay networking will never work, Martin. I mean, so actually I'm going to take a different tack on this, and it actually comes from, I think, the panel that was going on beforehand, and maybe I'm channeling my friends at the end of the panel here, which is that application developers, I would like to have them not be full stack developers, but effectively no stack developers, where they don't need to know what the hell is going on underneath them, and channeling what Martin was saying earlier, that they're able to program intent into the network. And then there is telemetry data, or whatever word we like to use, just spewing out of the system that then can be analyzed in real time or otherwise. Now, that's landing a couple of years from now for us to be able to build this, but finding an individual, and I think Martin has said this a variety of different ways, but I'm going to summarize it this way, which is that finding an individual who is developing their application, who actually will have the mental capacity to understand every other layer of everything that's going on underneath, with today it's hypervisors, tomorrow it's containers, the next day it's God knows what. Is everyone in the industry going to learn every aspect of everything just to get their job done? Probably not. They need to have some awareness, but if we can get to the point where you can say policy, or you can say intent, and you can say telemetry, or you can say big data, or whatever it is you like, but if we can get to the point where application developers in the DevOps community don't need to care about that stack, and we can have no stack developers, that will be a great day, and at least something to work towards.
So I don't have much to add here, but just that the first decade and a half I was working for Cisco, right? So, and then I joined software companies like Red Hat and Docker. So the immediate change I saw is the mindset, right? In Red Hat, in Cisco, when I used to debug problems, right, the first thing I ask customers is, I cannot reproduce it, can you give me the logs, right? They say, I didn't enable the debugs at log, right? There it goes. So I can't even reproduce the problem, I can't even know what has happened beforehand, right? When it comes to the software world, it's completely different, right? You have data all the time. So it's like, it's insane to even ask people to enable a debug, right? So why is that the case, right? In networking, we are so in the back edges, right? In networking, especially the physical device companies, right? Where we have to change, right? SDN has come and changed the game a little bit there, where at least now, big vendors are enabling, at least giving ability to run some software in their devices. Before that, we are at the mercy of debug XXX, YYY, right? And if the user has not enabled it, then good luck. You just cannot have any information about it. And especially in distributed systems like networking, it's practically impossible to even debug with such log information, right? We should enable the end users to run software in the devices in a safe way, right? Why can't I run a container in a Nexus OS, which is a Linux system, right? I should be able to run a Docker image right there, and I want to collect whatever data I want to from the hardware. Why is it difficult, right? So those are the things we have to just change, and to me, it's a surprising fact which we haven't changed yet, right? Slowly it's changing, yes, but.
Yeah, I think, having talked, I spent a lot of time over the last couple of years meeting with a lot of the cloud providers and the large scale, say the Facebooks and the Twitters and folks, just because people are good about sharing, right, at least at an infrastructure level, because it's not necessarily competitive there, kind of what they've done. And so it's quite interesting because I come from, I worked at Cisco and Sun and things, and I've been in sort of financial services for 4 years. And what I realize is like the applications just aren't cloud native. They're not ready to do this. So when you sort of start out with a cloud and you build your applications cloud native, right, you can sort of do all these sort of DevOps and infrastructure blends, right? You can sort of program the infrastructure, program the network, That scares the crap out of our risk and control and information security people. Are you going to let the programmers touch the infrastructure? And when I first went out and talked to the application teams, it's like you feel like you sort of knock on their door. You say, I'm here from infrastructure to tell you about cloud. And they sort of slam the door in your face because they think it's like going and saying, I'm here from the government. I'm here to help. And so I spend a lot of time saying, I'm here to help. I'll do something for you, not to you, right? Give them these kinds of abstractions that you've all talked about, and to sort of. But they haven't really built their applications to be cloud scale. They have built them to sort of run virtualized, and to be able to sort of vMotion around, and we have automated all this infrastructure provisioning. But once you sort of automate it, you sort of static. I think the big change is this very dynamic nature of the infrastructure being itself agile and sort of dynamically changing, while the applications are trying to stay alive. And until they build their applications to be able to handle multiple faults without taking down the application, they're not really going to run real well in the cloud. They're going to be stuck in these traditional, what we'll call vertical scaling, or sort of single scale architectures. They're not sort of horizontally scaling, because you get a whole different resiliency model out of horizontal scaling. And so I think that all these issues I was just sort of throwing out there to talk to you about were really about, if you're going to horizontally scale, that's a very dynamic way of the application sort of growing itself and shrinking itself. And the application teams don't even have blueprints for many of them how to do that. Google's invented theirs, and Amazon's invented theirs, and Twitter's invented theirs, and everybody's invented theirs. I remember I was over at Facebook, and it was fascinating because they were sort of really proud they just deployed their 1 millionth server. I said, well, what's your biggest problem? They said, our power bill. And I said, really? I said, you guys don't virtualize? And they said, no, but we might have to do that now because we have a second app called WhatsApp. They have 2 apps now. I have 6,000. I couldn't survive if I didn't virtualize. Okay, 6,000 apps. So if you just have one app, you don't have to virtualize. If you have 2, then you have to think about it. So get your power bill down. So this is a different kind of scaling problem that we have to deal with, and I think that's kind of the gap I see with a lot of the cloud providers is our application guys just don't know how to build an app to run and to really leverage it the way that the cloud providers leverage it themselves. So I don't know if you guys just randomly, anybody have any thoughts on that? Because I think it's going to take us several more years despite the hype.
So the future is here, right? So the Docker containers are exactly there to solve the problem, where application developers develop their app, the laptop, right? And they don't have to worry about where it's going to be run, right? That's exactly where the future is, and we are there, right now. So that's why I was trying to explain in the beginning that Docker containers are not just like virtual machines; they are actually application abstraction, really, right? So.
Go ahead.
Thanks. I agree that the abstraction point is a really important point. We are at this awkward moment in the industry where people are recognizing en masse that they actually have written their applications wrong, right? And they need to do it again. Most of these applications, you can't sort of change it to be horizontally scalable. It's you blow it up and you put the pieces back together. And while we're in this awkward teenage phase, it's important that technologies like Docker make it possible to bridge these worlds, right? Where you provide an on-ramp with as little friction as possible to take your VM and put it into a container, right? Most everybody in Docker space sort of accepts that running multiple applications in a single container is not really best practice, right? But it works, and it's totally doable, and Docker's got a bunch of features that make it possible to do that elegantly. And if that's how you sort of bridge the gap from I had a physical machine, then I had a virtual machine, now I've got a containerized virtual machine, and over time you can take these pieces off and you can carve off chunks and microsegment or microservice your application. Then these are the important bridges, right? And systems like Kubernetes and Docker and Mesos go to great lengths to provide these abstractions that maybe aren't exactly what people should be doing, but they help them do it because they're going to do it anyway, right? They're going to do it whether we want them to or not. So let's help them at least do it in a way that doesn't hurt themselves. And so it's things like bringing DNS, right, where people make assumptions that DNS is stable. Well, we can do things there to make it not break so often.
So if you don't mind me riffing off of that for a bit, just into the networking world for a second, which is we are in this awkward, nervous phase, but it's also a very frustrating phase. And I say that, and I'm going to focus on NFV for a second, because to date, NFV architectures, given the application structures, has been a complete lift and shift from physical to virtual. It's actually kind of boring. Like it's a mildly interesting problem, because all you did was take what was working there and have it work up there, and okay, we'll tune and crank on computers. Look, I've spent years working on this stuff, so I'm speaking a little bit with my tongue in my cheek, because I'm right in the middle of this. But when you link together, Greg, the earlier conversation you had about firewalls and load balancers and whatever else you want in their IPSs, whatever the case, right now those applications do not lend themselves to be cloud native, and we are at the point where we've got to find the right use cases where the application has been blown up. You mentioned the firewalls, you mentioned, if you also talk about mobile gateways, you start talking about some of these things, they are hourglass designs in their design of how traffic flows through them. Different type of application than maybe Google is doing. But for NFV to become containerized and useful, those designs will have to fundamentally modify to take advantage of the microservices architecture that's there. So this is in a different term of the word hybrid. Are we going to start building application workflows in what you were describing of how your applications work, where some are running physical, some are lift and shifted, some are using cloud native? How is that going to be orchestrated across all of these environments? It's probably a scene we're going to see in this movie, just because it is mayhem out there, as Martin was mentioning. I would love it if we could get to the point where everything is cloud native, and now I'm focusing on specific use cases, workloads, workflows, etc., where there's extreme advantage to going towards cloud native to prove the point that even in IO intensive applications that it's possible, and a huge advantage to do so. But
yeah,
there you have it.
So I think that tracks well, because I think what I've seen in the last year with at least our own application teams is a willingness to take at least we'll say the northbound tier or the web tier, maybe the middleware tier, break it into microservices, and then containers becomes the thing to run that. So I see containers as the bridge into the hybrid cloud, because first they'll re-architect the front end of the application to be somewhat horizontally scaling with some distributed caching, push that out into containers. The stateful stuff, the vertically scaling stuff, will stay back in the private cloud, and you'll just have real good network connectivity between them, and you'll have to extend the virtual network out through a VPC model and a VPN model to kind of wrap that sort of front end edge out there as an extension of the core. I think that's kind of what we're going to see over the next 18 to 24 months.
It's possible.
Yeah, we can achieve that, right? But I think the orchestration piece then becomes really, really critical. Was it going to be Rancher, Mesos, Kubernetes, or something? All of the above, right?
Can I make just one super small comment that I think
Sure.
that I think there are some problems that are fundamentally hard. And we spend decades moving around the problem without reducing it, right? It's like when you wake up in the morning and you want to make your bed, and you're making your bed, but you've got that bump, and instead of actually getting rid of the bump, you move it over by the pillow because it looks better by the pillow or by the wall. And I think distributed systems is one of those problems. It is a fundamentally hard problem, and in the languages community, we try to write languages like Sisal. Remember Sisal? You can write it's a serial program, but it runs in parallel, and it never works because it's really hard. And I think the cloud native problem reduces to the problem of writing a distributed system, which is just hard. So you can rein it by basically limiting the problem space, saying, okay, you can only do it in these ways, and you can rate it in certain number of ways, but if you want to actually scale something, you have to have really good people do this. And so I think that this is a big challenge for us as a community as things go hybrid and cloud native, and how do you write distributed systems that scale and provide the guarantees that you want on state. And I actually think this is the challenge of the industry going forward.
Great. So maybe we can turn to the audience for some questions. I'm sure some people, after that level of dialogue, probably has lots of questions. Okay, we'll go to the microphone over there. Just makes my head hurt, actually.
Hi, everyone. It's been a good talk. I just had a question really about trying to answer like the business need and what the concern is, right? What's really stopping us from designers is saying, hey, the business just cares about that. They don't necessarily care about the network. They just want to know, hey, we're making money on this or we're doing something great. And I just want to be able to use it on, on our own cloud and any other cloud, right? I kind of think about like with the phone keypad, for example, right? For a long time, decades, right? Still same interface. Like when Captain America woke up tomorrow, and I still know how to use it, right? And it's not a, hey, well now I went to Japan, so I can't use that same one, or I was right. That's kind of like what the business is looking for. They want to know, hey, here's an app that's going to do this for us. I just want to be able to work at the end of the cloud or otherwise. So how do we answer that? How do we give that to the business?
I think fundamentally you're talking about coupling, right? You're talking about the idea that you run in Amazon and you tend to use Amazon services and you build your AMIs and you're used to the workflow of working with Amazon, and then one day Amazon's pricing goes up and you say, well, I'm gonna look at GCE, or I'm gonna look at Azure, or I'm gonna look at doing something else, right? And you can't. Right? Because you've now got hundreds, thousands of man hours invested in building this coupling that you didn't really want in the first place, but it was a side effect of what you built. And so I think that we're in this place now where containers give you an abstraction that you don't couple to your host OS, at least very loosely couple, that systems like Kubernetes or Mesos sort of divorce you from understanding that you're running in AWS or that you're running in GCE. You don't need to think about it. I can speak to Kubernetes, at least in particular. It's something that is very much in the front of our brain. Every time we add a feature, we are careful to make sure that it's not something that accidentally couples people into systems, not even intentionally, just accidentally. And we get a lot of really well-meaning feature requests of, can I have this information or can I have that information? And we don't even want people to couple to Kubernetes if we can avoid having them couple to it, because who knows, 10 years from now, there'll be a different system managing the workload, but hopefully your app still works and you didn't have to blow up your app and start over. So we try to be really, really careful of this thing. And every time I hear a story of somebody who brought up Kubernetes on Amazon and then made their app work there and then picked it up and moved it to on-prem, or they started on-prem and they moved to Google or whatever, those are the stories that make me most excited.
Yeah, the joke is we solve all problems in computer science with a level of indirection, right? So it's really important to have this to find the right patterns, as Tim was saying, to build your applications that are independent of the underlying infrastructure. And that was the fundamental idea behind things like Kubernetes and Mesos. Mesos is Greek for middle, so it's between the hardware and the software. That's what it's for.
Right. So to answer this problem, the question, right? So Docker mission, the mission is to have tools of mass innovation, right? So the idea is that provide a frictionless way for application developers to develop an app, and they have the choice of choosing between which cloud they want to park it on. So as you said, right, we don't want to get tied to an Amazon or a Google or Microsoft. So that's exactly the fundamental abstraction that Docker-like solution provides, is that you concentrate as a businessman, concentrate on your app, don't worry about the infrastructure, right? And if you look at the Docker releases, as you can see, we had this great solution for the compute so far, and now we have this release 1.9 where we also abstracted the same thing for networking as well. So now we can actually enable hybrid cloud solutions where you can have a distributed application running partly in your, one of my friends calls it minimal viable data center within your own private cloud, whatever it could be, your laptop for that matter. And then you can have your big system running in Amazon, Microsoft, Google at the same time, and you can orchestrate them accordingly, right? So solutions like Swarm, Kubernetes, we all try to solve the exact same problem, where don't tie yourself to an infrastructure. Either it's your VM, whether it is your public cloud, but you don't have to, right? So the container is the momentum that is actually taking you to the next level, actually.
Any other questions?
So if the major need is this policy framework, where is that framework going to come from? Is it going to come from vendors working together? Is it going to come from the OSCON community? Where do you see that emerging?
Yeah, I think there's a real opportunity to collaborate and find a common language there. I think there's multiple approaches here, multiple groups, companies attacking the problem in similar ways, and I think in the end, portability is the higher order bit here. So there's a lot of opportunity for collaboration.
So my opinion on where the policy language is going to emerge, a number of different places. Creating new languages is outstandingly hard. There is no one language that we can conceive of, from a lack of a design and go through this. But it will be an open source, and hopefully the first place it emerges is actually at the PaaS layer, at least. Talking about policy intent way down at a chip driver level or some of these other pieces is necessary but not sufficient to give the app developers who are working in containers and across these orchestrated systems the intent that they want to be able to program into this. And so it's going to be way up at the top of the stack, but it's going to be able to interact with the pieces down below, et cetera.
I'm going to go back to one more thing that Ken said. I thought sort of stuck with me is this idea that the physical layer, you've got to really carefully architect and design all the pieces of that, right? So number one, they can be automated and orchestrated. It has to sort of be sort of multi-vendor friendly and somewhat agnostic to sort of like what talks to it, as long as it's standard protocols. The thing that we see particularly is just this extreme growth of data, right, flowing across our data centers, north-south, east-west, between data centers, whether it's big data technology, disaster recovery. I mean, the data volumes are just getting more and more astronomical, right? And everybody wants the data in flight, just in time delivered to where they need it. So I think that's really put a lot of pressure on traditional network architectures, right? Our fiber channel systems are under duress, right? We're going to sort of scale out storage, but it creates an interesting problem. Some little app sends off some 64-byte packet, asking for some information, and 200 gigabytes comes pouring back over the network, into that 1 gig port, from your 40 gig, storage fabric. So as networking guys, what should we be doing to sort of deal with this impedance problem other than we can't upgrade everybody to 40 gig? So how do we manage let's say it's at least it's a 10 gig server sending a 64-byte packet out that gets 200 gigabytes of MongoDB data back across multiple spindles of disks. How do we deal with that problem in the network?
Deep buffers.
Really deep.
So what is obviously emerging in the networking space is some amount of reactive networking that can be done. First of all, understanding that 64K packet or whatever you said made this particular query. As you said earlier, the telemetry is just emerging out of the network to actually find that was the fault that happened. Being able to create load engineered data centers is state of the art at this particular point. Even if you knew that was going to by accident happen or on purpose happen, be able to move traffic off that port, whatever the case, that amount of reactivity is at the point. If your application is written such that it's going to make that type of request, back to the DevOps guy, start laying out, find Joe or whatever you said and say, guess what, you wrote that wrong. Because this is the consequence of the way you did that check-in or whatever the case is, and that's bad. And don't do that again, and instead use these other tools that are available to get your job done. But that reactive all the way back to the app, today, right now, I posit it's pretty hard to see that out of the stack in the system right now that packet from that container that was there for 10 seconds caused this to happen. So, kind of dialing this back, Greg, that whole issue of being able to push it up to the PaaS layer to the application developer to find the
You've got to have the
DevOps
end-to-end visibility of what's going on.
Absolutely.
Well, I'm really confused by the assumption that an application trying to go through a lot of data represents a programming error. I think that we're entering an era where the ability to make use of very large amounts of data is critical to competitive advantage. And this is where the network needs to embrace and support these applications, not flag them as failures. And this is where we're building extremely high density, high bandwidth switches that have the buffering required to buffer these bursts and deliver them to applications along with everything else going on in the network without interfering with unrelated flows. That's the kind of east-west fabric that you need to build to support all of your applications on a common fabric and benefit from cloud scale and cloud economics. I think keeping the physical network here separate, isolated, virtualizing the topologies on top, and providing that sort of clean, no excuses bandwidth, being able to fully saturate all ports simultaneously, removes the barriers from the application author. And the instinct of other technologies to sort of push back to flow control, to try to throttle back the transmission of data to avoid packet drops that way, rather than through simply buffering the traffic and then delivering it, results in head-of-line blocking, results in congestion collapse in the network. The right way is more buffer. And I wasn't kidding. And this is what we've seen in Hadoop deployments. We've seen this in IP storage and scale-out storage. Proper buffering in the network is poorly understood, but a very important determiner of performance. Without proper buffering, when everyone sort of intuitively grasps that packet drop is probably not good. But I think the dynamic that people haven't widely grasped is what actually happens when you're in your Hadoop shuffle. And all the sources start at almost the same time, pushing more data through the network than you can handle in a millisecond, so some data has to get buffered. And then because the switches have inadequate buffering, things start to drop. The effect that you get is not what you expect. It's not a scaling back of the throughput uniformly across the sources. TCP behavior is tremendously unfair in the presence of small buffers. Basically, whoever goes first, even by a very small margin, captures the available buffers, gets full throughput, while flows that arrive just a very short amount of time later, potentially milliseconds later, get almost all their traffic dropped and throttle way back. And the consequence of this in a Hadoop environment is that 95% of your job is done fairly quickly, and the last 5% takes another hour. Everybody's wondering why this happened. And it's because of bandwidth capture through inadequate buffering. So I think for good performance of these most demanding applications on the storage side, you need deep buffered switches.
Our data is growing at 300% per annum, so we got to solve this problem.